Lecture 4: Extended ER Feature. In the previous lecture, Lecture 3, we studied the basic ER model, which can be used to most database features. However, as database complexity increases, it becomes necessary to use some extended ER features to accurately represent the database schema. This extended feature helps in better designing and structuring complex data relationships. Specialization. In ER model, sometimes we need to subgroup an entity set into other entity set that have distinct characteristics. Specialization is the process of dividing an entity set into smaller, more specific sub-entity sets based on functionalities, special attributes, or specific roles. It follows a top-down approach, meaning we start from a general entity and break it down into more specific sub-entities. As we see on right-hand side, there is an example of specialization. Considering an entity set person, this entity set can be divided into customer, students, and employee based on their roles. Here, personal is a superclass and customer, students, and employee are subclasses. There exists an easier relationship between the superclasses and its subclasses. Specialization is represented in a ER diagram using a triangle component that connects the superclasses to its subclasses. So we use specialization? First is attribute specific specialization. Some attributes may be applicable only to certain entities. For example, students have attributes like student ID and course. Employee have attributes like employee ID and salary. These attributes are not relevant for the general person entity. Next, better database design. A database designer can clearly show the distinguished feature of each subentity. Next, improves query performance. Next, refines database blueprint. Specialization helps in organizing and structuring the database effectively. Next, generalization. Generalization is the reverse of specialization. Instead of breaking down an entity into sub-entities, generalization combines multiple entity sets into a single entity set. It follows a bottom-up approach, where we start from multiple specific entities and group them into more general entity set. Example of generalization. Consider the entity set car, bike, and truck. Each of these entities has attributes like registration number, color, and owner. Since they share common attributes, we can generalize them into single entity called vehicle. Here car, bike, and truck become subclasses, and vehicle is a superclass. Generalization helps in reducing redundancy by grouping common attribute into one superclass. So why we use generalization? Generalization avoids data duplication. Instead of repeating common attributes across multiple entities, they are stored in a common superclasses. Next, for this is simplified schema. The database schema becomes more structured and easier to manage. Third one is efficient storage. Reduces memory uses by avoiding unnecessary attribute repetition. So the difference between specialization and generalization. As we see in specialization means breaking down an entity into sub-entity. So generalization is combining multiple entities into single entity. Specialization approach is top-down approach. Generalization approach is bottom-up. The purpose of specialization is to show specific distinction among entities. Generalization purpose is to reduce redundancy by merging similar entities. As we seen, example of specialization is person, which can be customer, student, employee. And generalization example is car, bike, truck, which comes under vehicle. Use case of specialization is when certain attributes apply to only some entities. Generalization use case when multiple entities share common attributes. Conclusion. Specialization and generalization are key concepts in extended ER modeling. Specialization allows us to refine a database schema by breaking down entities into more specific sub-entities. Generalization simplifies the schema by combining multiple similar entities into one. Both approach improves database efficiently and both approach improve database query performance and structure. Using this technique, database designer can create a well-optimized and logically structured database schema. Thank you.